Welcome to my presentation. In this presentation, let us look at some vector operations in 3 dimensions. Let us look at some examples. Let us say we have an example of this type. If A1 is a vector which has components, let me write this a bit more clear here. If A1 is a vector which has 3i minus 2j plus k, and then if A2 is another vector which has components 2i minus 4j minus 3k, and if we have A3 as another vector and if the components of those are negative I plus 2j plus 2k, then we want to find the following things. 1. We want to find the magnitude of vector A and vector A1 and vector A3. Okay. Second, we want to find the magnitude of vector A1 plus vector A2 plus vector A3. Third, we want to find the magnitude of 2 times vector A1 minus 3 times vector A2 minus 5 times vector A3. Let's say these are some of the questions we have, and then let's get started. The first question we have is we want to find the magnitude of A1 and A3. If A1 is given to us as 3i minus 2j plus k, the magnitude of vector A is going to be represented like that, and we can write this one as the square root of 3 squared plus negative 2 squared plus 1 squared, like that. Therefore, when we simplify this is going to be 9 plus 4 plus 1 under the radical symbol. Therefore, this is going to be 9 plus 1 is 10 plus 4 is going to be equal to 14. This is 9 plus 4 plus 1. Therefore, this is going to be 9 plus 1 is 10, 10 plus 4 is going to be equal to 14. The square root of 14 is that magnitude of A1. Magnitude of A3, on the other hand, the magnitude of vector A3 is going to be A3 is negative I plus 2j plus 2k, therefore negative 1 raised to the power of 2 plus 2 squared plus 2 squared, right? Therefore negative 1 raised to the power of 2 is 1, 2 squared is 4, 2 squared is 4, therefore 4 plus 4 is 8, 8 plus 1 is 9, therefore square root of 9 is equal to 3. So therefore that is our answer. In here, square root of 14 is our answer. So that's the first part of the question. The second part of the question is, the second question we have is we want to find the magnitude of A1 plus A2 plus A3. First, let us find A1 plus A2 plus A3. Then we'll find the magnitude of that. So the values what we have here are as follows, isn't it? A1, the components are 3i minus 2j plus k, plus A2 is 2i minus 4j minus 3k, and then vector A3 is negative I plus 2j plus 2k. Therefore, when we sum them up, we're going to sum the similar terms. All the I will combine all the I terms, combine all the j terms, and combine all the k terms. So one way to write it out is we can just add them as we see them, or we can also combine them together. Let us add them together as we go. 3i plus 2i is 5i minus 1i is going to be equal to 4i. So we simplified it right there. Negative 2j plus negative 4j is negative 6j. Negative 6j plus 2j is equal to negative 4j. Okay, it's that simple. Plus k minus 3k is minus 2k. Minus 2k plus 2k is going to be equal to 0k. Just 0 or just 0k. We'll just write it as 0k. What we need here is we need to find the magnitude of this, the sum of these three vectors, and the way to represent that is as follows. The magnitude is represented by two lines on either side, and therefore we're going to take the elements of this sum of these three vectors, which is going to be 4 squared plus negative 4 squared plus 0 squared. Okay, so therefore 4 squared is 16 plus negative 4 squared is 16, 0 squared is 0. So therefore 16 plus 16 is 32. Therefore we can write that as 32. We can also write that as 32 as 16 times 2 is 32. 16 is a perfect square, and therefore I can pull out the 4 outside and then write it out as 4 square root of 2. This is square root of 2, like that, and that is our answer. That is where we want to leave it. Okay, and the third one we have here is as follows. The third question we have is, he's asking us to find the product of 2 times vector a1 minus 3 times vector a2 minus 5 times vector a3. So the way to do that, we want to find the magnitude of that. So first we will multiply the scalars to the given vectors, and then we'll find the magnitude of that. So we can write this one as 2 times vector a is given to us as 3i minus 2j plus k minus 3 times vector a2 is given to us as 2i minus 4j minus 3k, like that, and then minus 5 times a3 is given to us as negative I plus 2j plus 2k, like that. And now it is just a matter of distributing the constants to every one of the components inside the vectors, and then collecting the like terms, and then finding the magnitude of that product vector. So this is, let's simplify this. 2 times 3i is 6i, minus 2 times 2 is 4j, plus 2 times 1 is plus 2k, minus 6i plus 12j plus 9k. I'm just distributing the negative 3 to every one of the terms inside the parentheses. And then negative 5 times negative I is positive 5i, minus 10j minus 10k. So we have all the elements written down. And now we will collect all the like terms. What we have here is 6i minus 6i plus 5i, all the I terms together. These are all the I terms. Then minus 4j plus 12j minus 10j. These are all the like terms. And then we have plus 2k plus 9k minus 10k. These are all the k terms. So therefore, when we simplify them, this is going to simplify as follows. We have this 6i cancels out, leaving us with just 5i. Then we have negative 4j plus 12j will be positive 8j. 8j minus 10j will be negative 2j. And then we have 2k plus 9k will be 11k. 11k minus 10k will be just 1k or just k, like that. So we got the simplified form in that manner. Now we want to find the magnitude of this. 2a1 plus minus 3a2 minus 5 vector a3, and we want to find the magnitude of this, and that is going to be equal to 5 squared plus minus 2 squared plus 1 squared, like that. When we simplify this, this is going to simplify to 25 plus 4 plus 1, right? So this is going to simplify to 25 plus 4 is 29, 29 plus 1 is equal to 30. So we cannot simplify this any further, so therefore we're going to leave it there. So the magnitude of twice the vector a1 minus thrice the vector a2 minus 5 times the vector a3 is going to be equal to square root of 30. So this is the way we can use the properties of vectors to perform operations in 3 dimensions. In my next presentation, we shall look at some more examples using the properties of vectors to simplify vector operations in 3 dimensions.